The last section here in chapter 2 kind of doesn't feel like it matches with the rest of chapter 2 unless you realize what we're going to be doing with eventually circles is finding the domain and range of these relations, because circles can be graphed on a coordinate grid. They won't pass the vertical or horizontal line test, but we will be able to graph them as if they're a relation. But before we get to circles, we need to go over a few geometry formulas that you may have forgotten. These are the distance and midpoint formulas. The distance formula finds the distance between 2 points, and it is as follows. Distance is the square root of x squared, or what? x2 minus x1 squared plus y2 minus y1 squared. So again, this is the distance between 2 points on a coordinate grid. We can also use a formula called the midpoint formula to figure out what the midpoint between 2 coordinate points is. So midpoint, again, is halfway between one point and the other. It will be a place on a coordinate grid, and all we do to find the midpoint is essentially take the average of the x values and the average of the y values. So x1 plus x2 divide by 2. Sum, divide by how many you're adding up. And then y1 plus y2 divide by 2. So these first 2 questions are going to have us use those formulas to find the distance, then midpoint between 2 points. The first one, when we're finding the distance, it's going to ask you to write the answer in simplified radical form, which means we can't just go straight to a calculator. We're going to have to evaluate and calculate this on our own. Then we're going to go to the calculator and round to, on our notes, 2 decimal places. Please make sure you're reading the questions to see how many decimal points it wants you to round to, because the book will change how many. It'll show up underneath the question in like a blue script. It'll say, please round your answer to blah, blah, blah decimal places. Do that. Okay. If we're finding the distance between these 2 points, just like when we use the slope formula, if you like the concept of labeling, this is x1, y1, this is x2, y2. I know that's incredibly small. You can label these coordinate points. You don't have to, but if that's helpful for you, go ahead and label them. Then when we start to use this distance formula, it is distance equal to the square root of x2, which is 3, minus x1, which is negative 1, squared, plus y2, negative 2, minus y1, 4, squared. Please make sure when you're doing this, see, I just had to extend my square root a little bit. I want it to actually fit all the way underneath there, because when I taught this lesson last year, my students weren't extending the line all the way across from their square root, and part of their numbers would escape their square root somehow, and mentally they wouldn't take the square root of it, and they just messed up. It's fine. Extend it all the way across. Now, I know we have minus a minus, and these are our notes, so we're showing an exorbitant amount of work. This becomes 3 plus 1 squared, and then negative 2 minus 4 squared. Again, this is an extra step you may not need. I'm just showing you a lot of work here in our notes, just to make sure we understand. Then we start calculating. What is 3 plus 1?
4.
What? 4. And then negative 2 minus 4? Negative 6. Now, notice that I still have these 2 terms in parentheses. Don't get rid of the parentheses until you've squared that value. Because 4 squared is positive 16. Negative 6 times negative 6 is back to being positive 36. If you accidentally get rid of those parentheses, you may accidentally square 6 and then make it negative instead of squaring negative 6. Okay, 16 plus 36, if we add those 2 numbers together, we would get 52. Is 52 a perfect square? No. Remember earlier when we were doing this in chapter, I think this was back in chapter 1. When we break the number 52 down, is it divisible by a perfect square? Yeah, which perfect square is it divisible by?
4.
It's divisible by 4. 52 divided by 4 is 13. Since it's divisible by a perfect square, we can take that perfect square root out of the square root, and we would have, in simplified radical form, square root of 52 is 2 times the square root of 13. Where did the 2 come from?
The 4.
Yeah, what is the square root of 4? 2. That's what gets to come out. That is simplified radical form. Sometimes when you just get the number underneath the radical, it can't simplify any, in which case it would just have been square root of 52. But if we can simplify it down, we will. Then we're going to turn to our calculator. And in your calculator, you're going to do 2 times the square root of 13. And we're going to round it to 2 decimal places. And what did you guys get when we rounded it to 2 decimal places? 7.21. I personally like to put the little squiggly equal signs, which means this is a rounded number. Your textbook won't always have that there, nor will you ever have to type it. I just like for myself to know that that is a rounded number that I got out of my calculator. Do we see the distance formula? We've used it before in geometry, but it's been a couple years, I know this. We understand a formula though? Plug it down, simplify, reduce it if needed. Let's find a midpoint. Finding the midpoint of the line segment with these endpoints, again, if it's helpful, you can label x1, y1, x2, y2. It's not necessary if you don't need it, but it does tell me exactly where these terms should go in the midpoint formula. The midpoint formula is just a coordinate point that we're building, where we take the average of the x's and the average of the y's to create the x and y. So we start to fill this out. We're going to do x1 plus x2 divided by 2. It's the average. And then y1 plus y2 divided by 2, average. We just need to simplify as much as possible. 1 plus -8, what do we get? -7. Then we have -6 plus -4. That's -10. Be prepared to either leave these as fractions or decimals. Again, just read the question carefully for how it asks. It doesn't say in this question how it wants it. I would prefer fractions personally. So we're going to leave -7 over 2, which is -3.5. But we're going to take this fraction, -10 over 2, and reduce it to -5. So we have the midpoint between those 2 points. If we were to plot these 2 points, the one that we created, if we measured it, would be halfway between the other 2 points in the middle. Okay, here's why we're going over distance and midpoint. If you notice this distance formula, we've got a giant square root, but what would happen if I squared both sides of this equation? What would happen to the giant square root?
It goes away.
It would go away, and then we'd square the distance, yes, between the 2 points. What that gives me is it leads me to the equation of a circle. You see this equation down here? I'm going to highlight multiple colors on this equation, so if you don't want to do this first one, that's fine. But we have this formula here, which is just like squaring both sides of the distance formula. This standard form of a circle is the squaring of the distance formula, and it gives us a circle in our coordinate plane. As we're working with a circle is defined to be the set of all points in a plane that are equidistant, distance formula, from a fixed point called the center of that circle. So we have the center of our circle. That is orange. And then the fixed distance from the circle's center to any point on the circle is called the radius. So what we've done is we've taken the distance formula, the distance between the center and the edge of the circle, and we've made it consistent. This distance is going to be the same as this distance, is going to be the same as this distance, and this distance, and this distance. That's a radius of a circle. Now, the center and the radius are seen exactly in the standard form equation of a circle. The center of any circle is the coordinate point h, k, created from the number subtracted from x in the squared and the number subtracted from y in the squared, equal to the radius, which is the squared term, that's the distance from the center to the circle. So much of our goal today is to use the idea of distance and midpoint, so distance and center, to graph and write equations for circles. Occasionally, these questions are also going to ask you questions about the relation, like, is it a function? The answer is no. They don't pass the vertical line test. Or what is the domain and range of this function? So it's still the idea of chapter 2 when we're graphing functions and talking about their attributes. We're just doing it with a circle. So example 3 says to write the standard form of the equation of a circle with the center at 0, 0. Okay, so we have a center at 0, 0 and a radius of 5. The center being at 0, 0 means that h is 0 and k is 0. The radius being 5 means that r is equal to 5. When we write the equation of the circle, all we have to do is substitute those values into their placement in the equation. So if we're doing that, it would look something like this. We would do x minus h, close parentheses, squared, plus y minus k, close parentheses, squared, equal to r squared. Now, since this is our first example, it's a very simplified example because we can simplify this down to simply, well, x minus 0 is x squared, and y minus 0 is y squared, and well, I just said the answer out loud. What's what? Oh my gosh. What is 5 squared? Okay, let me slow down my talking. This is the standard form of a circle that has a radius of 5 and a center at the origin, 0, 0. Our job is to graph the circle. And we're going to use the concept of the radius being the distance between our center and points on the line to do so. So first things first, we graph the center, which for us is at 0, 0. So boom, I have the center of the circle placed at the origin, 0, 0. The equation says 25, which is not that helpful for graphing, but this 5 that we squared to get the 25 is very helpful. My radius, or distance, between the center and the edge of my circle should be 5. So what I'm going to do is I'm going to count out 5 units in one direction. That's going to be a coordinate point on my circle. It should be the same distance all the way around the circle. So for us to graph this, what we're going to do is then we're going to go back to the center and we're going to count up 5 units and put another dot right there. Then we're going to go back to the center. We're going to count 5 units the other direction, and we're going to put a dot right there. Go back to the center, go straight down 5 units, so that we have 4 good coordinate points that we're going to try to connect with a perfect circle. You're not allowed to laugh at how badly I draw circles, okay? I know this about myself, and I usually use like a compass to do it well, but no compass fits on my iPad, so don't laugh, okay? But you're going to... You're just going to let it happen. That's actually not that bad. The one on my paper is horrible, but this one actually turned out okay. But this circle that we've connected, theoretically, should be equidistant if we were to measure... Oh, no, it's actually not that good now I'm looking at it from the front. If we were to measure all the way around the circle, those distances would be the same all the way around, from the center to the end. That's what a radius is. For us to graph it on paper, you're just going to count the radius up, the radius down, the radius left, and the radius right, and then try to connect the dots as smoothly as possible. Make sense?
So you just go like
5 each way, because it's equidistant, which means that we can go the easiest ways, which is up, down, left, and right, and then play connect the dots.
So it was like 3 0. You just go from 3 zeros to 3
You would count 5 up, 5 left, 5 right from 3, 0. That is a great segue to our next example. What if the center is not at the origin? Let's see. This time in example 4, we're not going to graph this one yet. It just says to write the standard form of the equation of the circle with a center at -2, 3 and a radius of 4. Okay? We can do this in one step. So I'm going to try to get us to be able to simplify quickly into one step. When we're doing this, the standard form of a circle was x minus the center point h, which was -2. Do we see how I made that minus a minus already into a plus? Close parentheses squared. Plus y minus the k value of the center, which is the y coordinate of the center, close parentheses squared. And it's equal to the radius squared. What is the radius?
4.
What is 4 squared? Boom. So the number you see in our final answer, it shouldn't say 4 squared. I actually want you to multiply that out. questions, comments could, yeah.
Which way you put the H and K?
It does. So the x value of the center is h, and the y value of the center is k. Think x goes with x, y goes with y. The x coordinate goes with the x minus, the y coordinate goes with the y minus. We use the letters HK, by the way, and this will come back to haunt us in chapter 7. Conics, which are different types of circles and ellipse and hyperbolas and all those things, which I will teach you about later, they all use the center as the letters H and K. So we're starting here using the letters H and K so that we know that that is a center point of whatever shape we're graphing. Okay, example 5, find the center and radius of the circle whose equation is x minus 2 squared plus y plus 4 squared equal to 9. We're going to graph the equation and then determine the domain and range of this function. So my question for you is, if the equation says x minus 2 squared, y plus 4 squared, what is the center value? What is the coordinate point of the center of the circle? Positive 2 and negative 4. Nice. So it should have a minus in the equation. And the only way it changes to a plus, like it does on the y's, is if we plug in a negative, because minus a minus is plus. What's the radius of the circle? 3. It says equal to 9. We know that is the radius squared. So what's the square root of 9? 3. Okay. Now, without graphing, let's see if we can answer and predict what our domain and our range is going to be. This is the center. This is how much we're going to move away from the center each direction. So if we moved to the left, since the x value is lefts and rights, we would subtract 3 from this number. What's 2 minus 3? Negative 1. So our domain is going to be from negative 1 to this number plus 3. 5. Let's talk about our range. Range is the y's, so now we're going to subtract 3 and add 3 to the y coordinate. What's negative 4 minus 3? Negative 7. And then what is negative 4 plus 3? Negative 1. Now if you're like, Miss Quigley, you're just like inventing these numbers. If that's the case, let's graph it first then and verify that this domain and range is correct. Because you might be able to convince yourself that this is the correct domain and range from a picture. So we graph the center first. You always start with the center. The center is at 2, negative 4. Let me zoom in. 2, negative 4. There's my center. How many spaces am I moving up, down, left, and right from the center? 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 3 spaces away from the center, up, down, left, and right. And then we don't laugh as much. Oof. Did y'all see that? That's horrible. I'm erasing. Yikes. Okay. There's my circle. If I was verifying the domain and range, how far to the left does this circle go?
3.
To the left?
1.
Negative 1. How far does it go to the right? 5. That's what we wrote for the domain. Left negative 1, right 5. We went 3 below the center point, or 3 to the left of the center point, 3 to the right of the center point. For the range, how low does this graph go? How high does this graph go? Negative 1, which is why we wrote negative 7, negative 1 as our range. You're adding and subtracting the radius length from the x's, then adding and subtracting the radius length from the y's to give me the domain and range. If that's like, that math ain't mathing, Miss Quigley, graph it. Domain is where it locates on the graph from left to right and where it locates on the graph from bottom to top for range. Yes? How did I get, like, mathematically?
Yeah.
I took 2 and I added 3 to it to get 5. Because we started at 2 and we moved to the left 3, which is at the level 5, at the column of 5.
Wait, so how'd you get -7?
How'd I get -7? I did that from the y value. Range is y's. So -4 minus 3, -4 plus 3.
So you add and subtract like the range.
Correct. You, for the domain, add and subtract the radius from this. For the range, add and subtract the radius from this.
How do you get the first number again?
This one or this number?
Down. Down.
This one. This is what I got when I subtracted 3 from 2.
Okay.
2 minus 3 is -1. In a pinch, graph it. You can see it on a graph. Question? No? Okay. Now there's one more skill that we're going to need to be able to do for graphing and talking about the attributes of circles. And that's changing a circle that's written in what's called general form. Remember, general form was equal to 0? This general form is also equal to 0. You also notice there's no parentheses here? Yikes. So it's not even close to standard form of a circle, so we can't find the h and the k or the radius without a significant amount of work. The way that this is going to work to change this equation from general form of a circle into standard form of the circle, which helps me graph the function, we are going to have to complete the square. Yay! Remember, completing the square is the version of solving a quadratic we used that used the b divided by 2 squared and had like the magic boxes. Y'all remember that? Okay, let's review how that works because this is completing the square advanced version. If we look at a general form of a circle, and we're writing it in standard form to then eventually identify the center and radius, graph, and talk about the domain and range. We first need to change the way this equation is written. So I'm going to take x squared plus y squared plus 4x minus 6y minus 23. I'm just rewriting it so you can see where I'm getting everything from. And I need to do some major rearranging. The major rearranging I am doing is as follows. I'm going to put the x terms together. X squared plus 4x. Then I'm going to put a magic box behind them. Then I'm going to group up the y terms. Y squared minus 6y. And I'm going to put another magic box. But so that I don't get confused, I like to put a circle. That's going to be equal to the constant term moved to the other side. So I took this -23 and I moved it to the other side. What does it become?
23.
Positive 23. Now, when we were completing the square, we had to put the magic box on both sides. But we have 2 magic boxes. So we put both magic boxes on both sides. Whoa. Don't do this part because you might regret it, but watch, look at if I scratch this part out, doesn't this just look like completing the square?
Yeah.
We're just doing it twice at the same time because we need to complete the square on the x's and complete the square on the y's at the same time. The formula is the same for both of them. The formula says to do b divided by 2 squared. What's the b term out of the x's part? 4. So we're going to do down here, we're going to do 4 divided by 2 squared. 4 divided by 2 is 2, and 2 squared is 4. The magic number that goes in the box, that's actually a box for me, is the number 4. So I would put a 4 here, and I would put a 4 here. We repeat the b divided by 2 squared. What's the b out of the y part? -6. So we're doing -6 divided by 2 squared, which is -3 squared, which is 9. The magic number that goes in the second box, which I have made a circle, is 9. You see how I've just done that step twice? We take the term next to x, that's the number that we're going to divide by 2 and square. Whatever we get after that goes in the magic box for the x's. Same thing, we're going to take the term next to the y, divide by 2 squared. Whatever I get when I finish goes in the second magic box. If we remember from when we completed the square, the next step was that it immediately factors to parentheses. The number that we get when we factor into the parentheses comes from the work step just above it. Before I squared this number, it was 2, drop a 2 down. Before I squared this number, it was -3, drop a -3 down. Now, I need to add all of these numbers together to make it equal to that number. What is 23 plus 4 plus 9? 27 plus 9, 36. Check it out, guys. We have a standard form of a circle already. Once we complete the square, we now can see the h, the k, and the r squared, which is all that we need to be able to determine the center, the radius, graph the function, and eventually do the domain and range. So once you've completed the square twice and condensed those numbers down, you're done with changing this around. Now we just do what we did in problems above. What is going to be the center for this circle? 2, 3. Remember opposite signs. Plus inside means we plugged in a negative. What's the radius? Don't say 36. 6. Because it's the square root of whatever that green number is. Let's graph it first, because I think I confused you trying to do the domain and range without a graph. So we would go over to our graph here, and we're going to put the center at -2, 3. Well, am I going to put the center at -2, 3? That is the question. Come on, work pen. -2, 3. My radius being 6 means that I do what to plot other points? Go 6 up, down, left, and right. So that means I end up at 9 on the top, -3 on the bottom, 4 on the right, and -8 on the left. I'm going to zoom out so my circle doesn't look horrendous. Because the bigger the circle, the worse I do. Oh. This is why we let computers graph circles for us, because that's what we get from me. Unless I was using a compass. But either way, I have my center. I have the radius from those 4 points I got, and I did my best to draw a circle. Not my best. How did I get 36? I added all of these numbers together. 23 that I moved, and then the 2 magic numbers combined to make 36. Now, the last question here, remember, it does ask us for the domain and range. So if we're asking or answering the domain question, the domain wants to know how far left and right does it go. What's the furthest to the left that this graph goes? What is this number? -8, and how far to the right did we graph it? 4. So my domain is from -8 to 4, which is what I'd get if I subtracted 6 from -2 and added 6 to -2. The distance, the radius. What is the range? How low does this graph go? -3. And how high does it go? 9, which is what I would get if I added and subtracted 6 to the y value. 3 minus 6 is -3. 3 plus 6 is 9.